All right, let's look at part one, standard form. Okay, so the information that stands out in standard form is that the y-intercept, right, just from looking at the equation, the two things I know is that it opens up and it crosses the y-axis at +6. Right, those are the only two pieces of information that I can obviously see, right? Like that's obvious. Everything else we have to work for. So A, B, and C, 2, -8, 6. We know that it opens up since A is positive. The y-intercept is at 6, more specifically 0,6. Dilation, that's the A value, just the number. All right, axis of symmetry. We can find the axis of symmetry by calculating -b over 2a. So -b. So b is already negative, so -8 over 2 times a, which is 2. All right, negative, that cancels. So we get 8 over 4, which is 2 times 2 is 4, right? 8 divided by 4, which is basically 2. So the axis of symmetry, always x equals 2. So x equals 2. There's the axis of symmetry. All right, when you have the axis of symmetry, you can reflect all the points that you know. We only know one point at this moment. We reflected across, and now somewhere on the axis of symmetry is going to be the vertex. So let's calculate that. So I know that the vertex is going to be at some x comma y. I know the x is 2, right? The axis of symmetry. Now we just have to figure out what the y is. So let's plug this into the original equation. So the original equation, 2x squared minus 8 times x plus 6. This should equal some y. So we're just plugging in 2. Right? We can plug in any number we want. But right now I want to plug in 2 because I want to figure out where the vertex is. Okay, this is going to be 2 squared is 4 times 2 is 8. 8 times 2 is 16 plus 6. So 8 take away 16 plus 6. 8 take away 16 is -8. -8 plus 6 is -2. So that means the y value is -2. So when x is 2, y is -2. All right, there's the vertex. And we know that it opens up, right? Like we know this. It goes towards the points. All right, so now the next step in the process is figuring out the points in between, right? Like what's the next point next to the axis of symmetry? And there's a couple different ways you could do this. We could just plug in 1 or 3 into the original equation and it'll give us a y value. There is another method. It's based on patterns, a very specific pattern. So the way the pattern works is that whatever length it's you could think of it as like the slope of, like finding the slope, right? I when you're graphing a line, you have rise over run. That gets you to the next point. You start at a point and then you go up some number over some number, up some number over some number, right? Like this is how you would form the dots, then you'd connect the dots to make the line. Okay, well, and that's in a linear equation. In a quadratic, there's something very similar, but The way you get to the next point is you start at the vertex, which is on the axis of symmetry. You go over one line, you square that distance because it's quadratic, which is nice in this case because 1 squared is 1. Then you take that number 1 and you multiply it by whatever your a value was. Right now, our a value was 2. So 1 times 2. So I went over 1, up 2. Let's just say if we went over 2 spots from the axis or from the vertex, which is on the axis of symmetry. So because I went over 2 lines, we square 2, which would be 4. 4 times 2 is 8. This red dot should be 8 spots up, 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And it is. So what I'm saying is there is a method. However far the distance is you go over from the vertex, you have to square that distance. Then take that number and multiply it times a. You'll see this more here in a second. We'll have more practice for sure. All right. We reflect this point across. And there's our quadratic. Or our parabola. We can connect the dots. Okay. We have to answer any more questions at the bottom? I feel like we do. There is a minimum, right? Because there's a low point, and the low point is always at the vertex. In this case, the vertex is 2, -2. The domain, -infinity to +infinity. And the range is always from the y value of the vertex towards one of the infinities. So we're at -2. So -2 towards infinity since it opens up. All right, let's see number 2. X squared minus 4x plus 3. This is going to be 1, 4, 3. Right, A, B, and C. 1, -4, 3. All right. The information that I get from this is that it crosses the y-axis at 3, and it opens up. So now, up, since A is positive, I'll abbreviate. Y-intercept is at 0, 3. The dilation is technically 1, but there's no stretch or anything, right? This is just the parent function shifted. All right, axis of symmetry. We have negative, that's part of the formula. B, which is -4, 2 times A. So we get negative. So 4 over 2, which is basically 2. So x is equal to 2. That means the axis of symmetry, the vertical line through x equals 2. And there it is. All right. Once we have the axis of symmetry, we can reflect the point that we know across the axis of symmetry. Okay, now let's just figure out where the vertex is. It's somewhere on the axis of symmetry. So let's plug into the original equation. So x squared minus 4x plus 3. So what x are we plugging in? The number that was the axis of symmetry, right? The x value. This is going to be 2 squared, which is 4, minus 8, which is -4, plus 3, which is -1. So the vertex we know is that x equals 2, -1. 2, -1. Okay, let's see if we can apply the method we just learned. So I go over 1 from the axis or from the vertex, and I square it. So 1 times 1, 1, and then times a, which in this scenario is 1. So 1 times 1 is 1. So we over 1, up 1. Over 1, up 1. And there it is. Erase this. All right, we can connect the dot. There it is. The arrows imply that it goes on forever. Okay. Answer some questions. We know that it has a minimum value, which is at the vertex. And the domain, all quadratics, is always all real numbers. The domain for any quadratic is all real numbers. And the range is going to be from the y value towards infinity since it opens up. All right, number 3. Y equals x squared plus x minus 6. So again, these are 1s. It's understood. It's our A, B, and C. 1, 1, negative 6. So right away, I know that it crosses the y-axis at negative 6. Crosses at negative 6. And does it open up or down? Opens up since A is positive. So 1, 1, negative 6. You know it opens down. Just kidding. It opens up because A is positive. The y-intercept is 0, negative 6. Right, it's a point. The dilation, we call it 1. And the axis is symmetry. All right. So negative b in this case was 1. A in this case is also 1. So the axis of symmetry here is going to be negative 1/2. X equals negative 1/2. Okay, fractions, yay. So negative 1/2. So there's a dotted line through x equals 1/2. And once we have that, we can reflect the only known point across the axis of symmetry. Okay, this is going to be interesting. Let's figure out the vertex. 1, 1, negative 6. So then this is going to be, all right, so the vertex, I'm going to work this out up here. Or we could do it right here. All right. Right now I know that the x value is negative 1/2. Let's figure out the y value. So this is going to be x squared plus x minus 6. So we have negative 1/2 squared, negative 1/2. All right, so when you square negative 1/2, you get 1/4. Right, positive 1/4 because negative times a negative. Minus 1/2 minus 6. All right, so a quarter minus a half. This is negative 1/2. Minus 6. Negative 6.5. So basically negative 6.5. Or what would that be as a fraction? 6 times 2 is 12. Plus 1 is 13. So 13/2. Negative. Just for counting purposes, graphing purposes, let's rock with negative 6.5. Is that correct? That's not correct. A quarter minus a half. A quarter minus a half is a quarter, not a half. Yo. So a quarter minus a half is negative 1/4. Minus 6. So this is going to be 6.25. Negative 6.25. All right, 6.25 is basically going to be right there. Okay, let's figure this out. So if I go to the right 1 unit, so right there, that's 1 unit. 1 squared is 1 times a. In this case, what is a? A should be 1. A is 1. So then I go up 1. So we go up 1 unit. Bam. Right here. Should be at a quarter. All right. We reflect this point across. Point. Okay, it's a little inaccurate. It's probably a little bit lower than that because it's 6.25, so it's going to be closer to 6 than anything. All right, just adjust. All right, that's better. All right, there they are. So if I go over 2 units, 1, 2, 2 squared is 4. 4 times 1 is 4. So I go up 4. 1, 2, 3, 4. So roughly here, but the graph doesn't really give you room to make a very precise spot. So we reflect it across. All right. I feel like that's good enough. All right. So we know that it opens up. So this is roughly what it looks like. I'm not going to work out all the details like the x-intercepts right now because that'll come in a later video. We just need certain characteristics, right? The axis of symmetry, the vertex, the y-intercept, and then a couple of other points. How do you get from the vertex to the other points? That's what we're looking at right now. Okay. So this is going to have a minimum value at 1/2 negative 6.25. The domain, all real numbers, and the range, negative 6.25 towards infinity. Okay. Let's look at the last one for this section. Okay, -4, 4, -4. It opens down and it crosses at -4. So -4, 4, -4. Opens down since a is negative. Y-intercept, x is 0, y is -4. The dilation is 4, right? Some people say -4, but negative tells us up or down, and the dilation, the factor that you're stretching by, is 4. Okay. Axis of symmetry, our go-to formula, negative, that's part of the formula. B b in this case is 4. 2 times a is negative 4. Okay, negative negative cancels. So we get 4 over 2 times 4 is 8, which is basically 1/2. Axis of symmetry again. X equals 1/2. Positive 1/2. So we get this line here. And once we get the axis of symmetry, we can reflect over any points that we know. Right now we know the y-intercept, so that reflects over. We know that it opens down, so the vertex is going to be somewhere above these two dots. Just keeping that in mind. Okay, so let's plug in 1/2 and see what happens. So this is 4x squared. It's actually negative 4 plus 4x minus 4. What are we plugging in? 1/2. 1/2. All right. So 1/2 squared is 1/4. 1/4 times negative 4 is just negative 1. Plus 4 times 1/2, that's 2, minus 4. So negative 1 plus 2 minus 4. Negative 1 plus 2 is 1. 1 minus 4, negative 3. So when x is 1/2, y is negative 3. Let's see if that's true. It is. That is above. So negative 3. Okay. Let's see if we can apply our little trick here. So I'm going to go over either way, left or right, doesn't matter. I'm going to go over 2 units. Well, I guess I could go over 1 unit. So if I go over 1 unit, 1 times 1 squared is 1 times a. So 1 times negative 4 is negative 4. So I'm going to go down 4. So 1, 2, 3, 4. And reflect this across. Okay, if I go over 2 units, it's going to get us off the graph. So this is good for now. Connect the dots, a little curve to it. It's going to go down here. All right. It has a maximum. Ooh, dude. I feel like this is our first one that opens down. Yeah, it is. Never mind. Confusing something else. All right. It opens down. So it has a max. So this is our first that has a max. A high point. So it's at the vertex. The domain, again, all real numbers. And the range. Okay, so this one's a maximum. So this one's going to go from negative infinity. Since it's a max, it's going to start at negative infinity and go towards the y value of the vertex. There it is. All right. If I want to put part 2 in this video, yeah, let's do it. You just fast forward. Okay. Intercept form. So when we're given an intercept form, the information that should be obvious just from looking are 1, that it opens up because the a value is 1. So I know it's positive. So this thing's going to open up. Not only that, but I know that the roots are going to be x equals negative 1 and x equals positive 3. Right? Inside lies. That's the idea here, is that it's always the opposite of what you see inside. You just flip the sign on the numbers that are in there. X minus 1, x equals 3. So negative 1 and 3. So these 2 points are obvious just from looking at the formula. The next step in the process here, right? Because depending on what form you have, there's different information that stands out, and there's a different step that you're going to do next. When you had standard form, we found the axis of symmetry first by using a formula. Okay, well, we're going to do the same thing now. We're going to find the axis of symmetry, but we don't need a formula, right? Because I have 2 roots, and I know that the axis of symmetry is going to fall exactly in the center of these 2 points. And that is going to be at x equals 1. Right, there's 2 units on each side. So there it is. Axis of symmetry is x equals 1, just from looking at it. Now, if you don't have a picture, which we have a picture, but if you didn't have the graph, you would just add up the roots, 3 plus -1, and divide by 2. That's basically how you find the average, and you'll find the midpoint, right? Going back to geometry, when you have the midpoint formula. Okay, so your x-intercepts, not x equals is a line. So it's going to be -1, 0, and 3, 0. It opens up. A is positive. The dilation is 1, right? Because A was 1. And axis of symmetry is x equals 1. Okay, here's the formula for finding the axis of symmetry if you wanted to use a formula. We didn't use a formula, we visually looked at the graph. So we're going to plug in x equals 1. So it was x minus 1, x plus 3. Ooh, that didn't sound right. X plus 1, x minus 3. It's because it's opposite. So x plus 1, x minus 3. All right, we're plugging in x equals 1. So this is going to be 1 plus 1, 1 minus 3. 1 plus 1 is 2. 1 minus 3 is -2. And the vertex is going to be at x equals 1, y equals -4. So 1, -4. And we know that it opens up. And the same little method will apply here. Whatever amount I go over, whichever way I decide to go, I'm going to the right. 1 time, 1 unit. So 1 squared is 1. 1 times A. A in this case is 1. So 1 times 1 is 1. There it is. We can reflect this point across the axis of symmetry and find what just so happens to be the y-intercept, right, at -3. So we can connect the dots. And just to show you, let's see if I go over 3 units, this would be 3 times 3 is 9. 9 times A, which was 1. 9 times 1 is 9. So I got to go up 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we can reflect it across. It's 3 away. 1, 2, 3. All right. Connect the dots. Okay, let's answer some questions. The y-intercept, what did we say it was? -3. So the y-intercept is going to be 0, -3. It opens up, so it has a minimum point. 1, -4. Domain, all row numbers. The range, it opens up, so it starts at the y value of the vertex and goes towards infinity. Okay, number 6. A is definitely negative. So this tells us that it opens down. And the roots, x equals 3, x equals negative 3. So 3 to negative 3. It's nice. Negative 3, 3. We know it opens down. Axis of symmetry is exactly in the middle of these. So that's nice. It's going to be the y-axis. Right, x equals 0. X equals 0. Okay. So intercepts are negative 3, comma 0. 3, comma 0. Down. A is negative. Dilation is 1. Axis of symmetry, x equals 0. Right, all that's from what we just figured out. We don't care about this because we visually looked. Okay, we're plugging in 0 to figure out the vertex. So right now the vertex we know is at x equals 0. We just got to figure out where the y value is. So this is going to be negative. X, which is 0 minus 3, 0 plus 3. I may have mixed those up, but that's okay because they're both 3. So I don't care about that. So negative 0 take away 3, 0 plus 3. Negative times a negative is positive. 3 times 3 is 9. So when x is 0, y is 9. 0, comma 9. Zero comma 9. All right, there it is, towards the top. Okay, we have a couple lines that we can go over. So if I go over 1, 1 times 1, 1 squared is 1, times a. A right now is negative 1. So we go down 1. If I go over 2, 2 squared is 4. 4 times a, 4 times negative 1, down 4. 1, 2, 3, 4. And then if we went over a third one, we'd get the point there. Okay, all these points get reflected across. Reflected across. We can connect the dots. All right. This is sufficient. Answer some question. Oh, let's see the y-intercept. 0. 0, negative 9. My bad. 0, negative 9. It opens down. So it has a maximum. The maximum is going to be at the vertex. It's always at the vertex. 0, 9. Domain. That never changes. And the range, since it opens down, it's going to start at negative infinity and go towards the y value of the vertex with the bracket. There it is. Is that it? No, we got quite a bit. All right, let's do another one. Keep it rocking. Okay, A is 2. This tells me it opens up. X equals negative 3, x equals 1. So you just flip the numbers real quick. Negative 3, 1. Negative 3, positive 1. Right away, I know the axis of symmetry. Right, visually, I can see that it's exactly in the middle. Exactly in the middle. So x equals negative 1. So just from analyzing, this is what we get. And it opens down. Okay, let's catch up. So this is going to be negative 3, comma 0, 1, comma 0. Down. A is negative. Dilation, I believe it was 2. Bro, A is positive. It's late. It's late, but we're catching them. We're catching the mistakes. All right, A is positive. It definitely opens down. Probably already knew that though. So it opens up. It opens up, not down. All right. Dilation's 2. Axis is symmetry. X equals -1. X equals -1. Vertex. Vertex is going to be 2 times -1 plus 3, -1 minus 1. I'm doing that from memory. Plus 3 minus 1. Yep. Okay. Let's crunch some numbers. This is 2. -1 plus 3. 2. -2. 2 times 2 is 4 times 2 is 8. Negative. So the vertex, when x is -1, y is -8. -1, -8. And it opens up. Yeah, it does. Okay. If I go over 1, 1 squared is 1. 1 times a should be 2. So I go up 2. Over 1, up 2. Over 1, up 2. Okay, we reflect that across. That just so happens to be the y-intercept, 0, -6. Connect the dots. Okay, 0, -6. Y-intercept we just said was 0, -6. It opens up, so it has a minimum value at the vertex. -1, -8. Domain, easy. All real numbers. The range, it opens up, so it starts at the vertex, the y value that is, and goes towards infinity. It's not bad. It's not bad at all. All right, last one for intercept form. Okay, negative. This one opens down. X equals 1, x equals -3. Right, like it shouldn't take long to look and see where the x's are, where the x intercepts are. +1, -3. It's opposite. Not only that, but once you find these points, I can see the axis of symmetry is exactly in the middle. 1, 2, 3, 4, so half. X equals -1. Okay. X-intercepts are -3, 0, 1, 0. Okay, it opens down. A is negative for sure. Dilation was 2, I believe. Yep. 2. And axis of symmetry, x equals -1. Right. Okay, we're plugging in -1 into the original equation. Okay, it was -3, so opposite and 1. All right, we're plugging in x into this. This is the original equation, right? Because here are your x's. And we're plugging in, substituting -1. This is going to be -2, 2, -2. It's interesting. 2 times 2 is 4 times 2 is 8. And then a negative times a negative is a positive. So the vertex, when x is -1, the y value is 8. -1, 8. So -1, 8. And this makes sense because it opens down. Okay, there are our points. Now, we just need to find the point that's next to the axis of symmetry. So I go over 1, and I do 1 times -2. So we go down 2. Oh, look, there's our y-intercept. And we reflect it across the x-axis. Okay, connect the dots. Okay, 0, 6. Y-intercept is 0, 6. It opens down, so it has a maximum point at the vertex, which we know is -1, 8. 8 looks funny. Domain, all real numbers, -infinity to infinity, in interval notation. All right, it opens down. So the range is going to go from -infinity to whatever the y value of the vertex is. In this case is 8, with a bracket. Okay, we're almost there. Vertex form. All right, this one's by far my favorite. This one's the easiest to work with, in my opinion, because the most crucial point, or the most crucial characteristic, the axis of symmetry and vertex, are obvious from like off the rip, right? So this is going to be the x value of the vertex. So x equals 3, y equals -1. I guess if you follow the notes, x is basically h, and this is basically k. H and k are the vertex, right? The vertex is at h, k. So the vertex right now is 3, -1, right? Opposite of the parentheses, and then whatever number's outside, it is what it is. So 3, -1. So 3, -1. There we are. The nice thing is that we know that the axis of symmetry goes through this point. Right, we know it. Not only that, I know that the a value in front is 1, so this means it opens up. Okay, that's cool. A is 1. So after we really haven't done any math yet, right? I haven't added anything, subtracted anything. But if we figure out the next points, we can. So if I go over 1 times a. So over 1 up 1. If I go over 2, right, square 2, 4. So 4 times a, 1, 2, 3, 4. And then if I go over 3, 3 squared is 9, right, the 1, 4, 9 rule. And then 9 times 1. So we go up 9 units. Puts me at 8. Which, by the way, is the y-intercept. All these points can get reflected across. And there it is. Connecting all the dots. Okay. Let's answer some questions. 3, -1. So 3, -1, that's the vertex. Axis of symmetry, that's the x value of the vertex. We know that it opens up, right? A was positive. The a value was on. Since it opens up, it has a minimum point at the vertex, which we said was 3, -1. The y-intercept, was it 8? Yeah, it was. The y-intercept is at 0, 8. Domain, negative infinity to infinity. You guessed it correctly. Good job. And then the range is going to be from the vertex, the y value, towards infinity. So -1 towards infinity. It goes quick, man. Right? It really shouldn't take longer. And I'm not rushing, right? I'm not rushing. I'm just answering the questions that I know. So this is where you want to be. See if you can pause it and do it as quick. A is -1, so I know it opens down. The vertex, so H is at -3, K is at +4. So the vertex is -3, 4. -3, +4. -3, +4. And we know that it's going to open downward, right? Something like that. So let's see if we can figure out the next point. If I go over 1, 1 times 1, 1. If I go over 2, it's 4 times -1. 1, 2, 3, 4. If I go over 3, 1, 2, 3, that's 3 squared, which is 9. 9 times -1. So it puts me at -5. Where I'm doing that because I'm trying to figure out where the y-intercept is. I guess I could have put the axis of symmetry through the vertex. Reflect all the points that I found across it. 1, 2, 3, 1, 2, 3. And then connect the dots. Okay. There she is. So let's plot the vertex. This is going to be -3, 4. Axis of symmetry through the x value. We know that it opens down, right? A was positive. A was negative, I'm sorry. It opens down. A was negative. Dilation, -1. Yep, -1. It does have a max point because it opened downward. The max is at the vertex. She said -3, 4. The y-intercept, we found that. X -5, or 0, -5. Domain, you guessed it, all row numbers. And then the range is going to go, since it opens down, it's -infinity up to whatever the y value of the vertex was. 4. Okay. Last page. All right. It opens down. For sure. A is negative. The H is 1. K is 2. So vertex is 1, 2. 1, 2. All right, axis of symmetry goes through it. And I know it opens down. I'm expecting it. So if I go over 1, square that distance. So 1 times A. A is -2. So I go down 2. If I go over 2 units, we square that. So 4. 4 times -2 is -8. There it is. And then I don't have enough room to go to the next one. But if I did, it would be 3. So 3 units. So 9. 9 times 2 is 18. I don't have 18 on here. All right. We can reflect all the points that we know across the axis of symmetry. There's the y-intercept. That's nice. Connect all the dots. And notice how it's like a U towards the bottom, towards the vertex. It's a U, not necessarily a V. It's, well, one is not a V. It's a U. Okay, this is going to be 1, 2. Axis of symmetry for this picture. X equals 1. It did open down. A was negative. The dilation was it 1? I feel like it was 1 because we multiplied by A. Oh no, it's negative 2. So the dilation is 2. Even though it's negative 2, we don't care about the negative for the dilation. All we look at is the number portion, right? Just the number. Since it opens down, it has a max point, which is at the vertex, which we said was 1, 2. Is that what we said? Yeah, we did. All right. And the y-intercept, the origin, 0, 0. That's nice. 0, 0. Domain, all real numbers. And then the range, since it opens down, it's going from negative infinity up to 2 with the bracket. All right. So negative infinity towards the y part of the vertex. All right, last one. Let's go. Oh, it would be a fraction. Okay. I ain't scared. So this is going to open down. The h, negative 2. The k, 1. So negative 2, 1. Negative 2, up 1. So here's the vertex. I know that the axis symmetry goes through it. Then so A is negative 1/4. Okay. If I go over 1, we square that distance. So 1 times a quarter, or times A, which is negative 1/4, which is negative quarter. So 0.25. All right, if I go over 2, that square is going to be 4. And 4 times a quarter, negative a quarter. 4s are going to cancel, making it 1. Right, 4 over 4 is basically what you get. It's negative 4. Or negative 4 over 4. All right, we can reflect this across. Okay, let's go over 3. So 3 squared is 9. 9 times a quarter is 9/4. So negative 9/4. So think about that in terms of decimal. How many 4s are in 9? 2, with 1 left over. So 2.25, negative 2.25. That's how much we have to go down. Negative 2.25. All right, even if we did one more, right? If we went over 4, that would be 4, square that distance. 4 times 4 is 16. So 16 times A. Again, 16 times 1/4. Negative, because it opens down. So 16 over 4, this would just be negative 4. Okay, so if we went over 4, we go down 4. 1, 2, 3, 4. All right, that's all I'm going to do. We'll reflect that over. 1, 2, 3, 4. And that's really all we need. Now, there's going to be more points that are similar, right? Like I could go over 5 and figure it out, but I don't need to. This is sufficient, right? Plus like 1 in the morning, so this is good. All right, vertex is going to be -2, 1. -2, 1. Axis symmetry. X equals -2, right? The x value of the vertex. We just saw that it opened down. A is negative. The dilation was 1/4, right? Just the A value. And since it opened down, it has a maximum value at the vertex, -2, 1. The y-intercept, did we find it? We did. It was at the origin, 0, 0. That's nice. I didn't even catch that. 0, 0. Domain, all row numbers. Range, since it opens down, it's going to go from -infinity up to the y value of the vertex. What was it? 1, 1. All right, guys. So, recapping, right? The 3 forms. Each form gives you a different piece of information. From that information, you can start working to find the axis of symmetry and the vertex. Unless it's the vertex form, which it would be obvious just from looking at the problem. All right, good luck. Catch you guys in the next video.